Hi, this is Mrs. Clark and welcome to my video on two-way tables. So you're going to be getting this piece of paper, you're going to cut it right here so these can go on two separate pages. We're going to fill this out together, and then you're going to get a third page that will go on a different page in your notebook. So follow along with me, fill in your note pages with me as we work. We'll do it together, write down what I write down as long as it makes sense for you in a way that will work for you in your notebook. Alright, so we're going to start off with just some definitions of two-way tables and relative frequencies. We talked about them throughout our lesson, but we didn't actually write them down and define them anywhere, so we're going to do that together now. Right. So a two-way table is a way of organizing data about two different categorical variables measured from the same set of individuals. Alright, so then we have relative frequencies, and we talked about them a little bit throughout our lesson, but a relative frequency is just a percent, so it's the percent of individuals that fall in each category But what's important is that we write this percent as a decimal. So put a little star here, written as a decimal. And then another important piece is that we can actually take a two-way table and convert it into a relative frequency table. So a two-way table can be converted into a relative frequency table. And we're going to actually do that on the next page. Together. But for now we're just going over these words. You need to grab two different color highlighters. One, you're going to highlight the word marginal frequency, and the other one you're going to highlight joint frequencies. And we're going to highlight where both of those are found in the table so you can see a good visual representation of those. Marginal frequencies are entries that are made in the total row and total column of the two-way table. So if we look at this table here, the total row is here. So these are our marginal frequencies, and then our total column is here. So all of those numbers are marginal frequencies. So here 18 is the total of dance, 16 is the total of sports, 16 is the total of TV, 50 is everybody in the table, 30 is the total of women, and 20 is the total of men. Then we have the joint frequencies. It says those are the entries that are made in the body of the table. So if I'm looking at the other ones, they're called joint because joints usually connect two things. So here, these two people are the men that also chose dance. And then these 10 people are the men that chose sports. And then the men that chose TV are these 8. And then we have the same thing with women. So each of these numbers that I'm highlighting are called joint frequencies because they represent two pieces of information at the same time. Now we're going to use this table that we just highlighted as a basis for the next page when we create some relative frequency tables. So if we look on this next page, we're going to be creating a relative frequency table, which is a whole table, and then we're going to do it by column, and then we're going to do it by row. So we're going to do 3 different types. So first, for the whole table, what we want is, since the relative frequency is a percent, we want to know what percent of men chose dance, what percent of men chose, or what percent of all the people were men that chose dance, what percent of all the people were men that chose sports, what percent of all the people were men that chose TV, etc. So what we're going to do is we're going to take all of the joint frequencies and we're going to divide them by the total for the table. So we're going to get it into a percentage. So this little fraction, remember, means to divide. So I would write that down if you want to make a note of how we got this table. So when you come back and look at it, you're going to say, oh, that's right, that's how I figured out these numbers. So what we're going to do is we're going to use this table here as a basis, and then we're going to transform these numbers into percentages. So in this spot, I'm going to take the 2, and it says to divide by the total for the table, so I'm going to divide it by 50. So in here, I'm going to do 2 divided by 50. So you're going to grab your calculator. We're going to do in the calculator 2 divided by 50. So 2 divided by 50, and we get 0.04. So that is the percentage written as a decimal of men that chose dance. So 2 divided by 50 is 0.04. So I'm going to write that here. So 0.04. I'm going to keep to 2 decimal places. And I'm going to do that for each of the cells in here. So I'm going to go to the women, and in this table, women were 16, so I'm going to do 16 divided by 50 to get this one. And you might want to just make a note of a few of them on the side here so remember how we got it. 16 divided by 50 is 0.32, so 0.32. And I can keep doing that for men in sports, women in sports, men in TV, women in TV. All of them are going to be divided by 50 in this case. So pause the video, calculate those out, check back to make sure that you did them correctly. Alright, so here's what your table should look like after dividing everything by 50. If you only did the 6 in the middle, the joint frequencies, if you total up 0.04 plus 0.20 plus 0.16, you get 0.40. You can also get 0.40 by taking the number that was here, which was 20, and dividing it by 50. So either way, these numbers are going to total up here, or I can do what was in the original table divided by 50, and I'll get this one. These numbers total up to 0.60. These total up to 0.36, these total up to 0.32, and these also total up to 0.32, and then these, this way total up to 1, and this way total up to 1. So whether you went through the whole table and divided everything by 50, or if you added them up and totaled them, you can do it either way, it'll come out to the same thing. Alright, so for the second table, what we're going to do is we're going to do it, not the whole table, I don't want it out of 50. I want it out of whatever the column is. So I'm going to do it by column. And columns go up and down. So here I'm going to take each of the joint frequencies, and instead of dividing it by 50, I'm going to divide it by the total for that column. So instead of 2 divided by 50 for this one, I'm going to need to look at the other table, and I'm going to do the total for that column. So I'm going to divide by 18 here. So for dance, 2 is going to get divided by 18, 16 divided by 18, 18 divided by 18. When I get to sports, the total is 16, so I got to divide everything by 16. When I get to TV, the total is 16, so I got to divide everything by 16. When I get to the total, it's 50, so I got to divide everything by 50. So this first column, I'm going to do 2 divided by 18. Then for the women, I'm going to do 16 divided by 18. Then for the total, I'm going to do 18 divided by 18. So when I do 2 divided by 18, I get 0.11111. So if we cut off after 2 decimals, the next number is a 1, so it's not going to round up, it's just going to stay the same. So I have 0.11. And then I'm going to do 16 divided by 18. It's 0.8888. So after the 88 is another 8, so it's going to round up to 0.89. And the last one, 18 divided by 18. We don't really need to do this one in the calculator because we know it's 1. I'm going to write 1.00 just so we follow that same trend of 2 decimal places. When I get to sports now, instead of dividing by 18, I'm going to divide by 16 because that was the total for sports. So I'm going to go through and do 10 divided by 16, 6 divided by 16, 16 divided by 16. When I get to TV, the total there was also 16, so I'm going to divide this one by 16. When I get to the total of that column was 50, so I'm going to divide by 50. So pause the video, do these calculations, and then check back. Alright, so here's what you should have gotten for the entire table. Notice that all of them are totaling to 1 at the bottom. So if you're looking at your column, these are totaling up this way, but they don't total up going side to side. So like, if you go in the column, they'll total to 1 at the bottom, but they won't total up if I go across the men. Those numbers are not going to add up to 0.40. The one that I circled specifically actually adds up to 1.01. I want to show you that. So if I do 0.63 plus 0.38, I get 1.01, and the reason is that 0.63 had to get rounded up and 0.38 had to get rounded up because we're following the rounding rules. So sometimes that will happen and it won't work out exactly to 1, but you might get 1.01 or you might get 0.99. Either case, it is still correct. I just want you to know that you might see that when you're working. Okay, so the last one here, we're going to do the same idea, but now we're going to apply it to the rows. So we're going to do it by row, which means we're going to take the joint frequency and we're going to divide it by the total for the row. So if I'm looking at the table here, the first row is going to get divided by 20, the second row is going to get divided by 30, the last row will get divided by 50. So we're going to divide by 20, we said, then by 30 on this one, and by 50 on the last one. So for the men's row, we have to do 2 divided by 20, 10 divided by 20, 8 divided by 20, 20 divided by 20. So go ahead and do that with your calculator, pause the video, come back and check your work. Here's what you should get for your table. Notice they do add up going this way. 0.10, 0.50, 0.40 equals 1. I do want to also point something out that I haven't been mentioning that I've been doing. Like for the first one exactly, if you do if you do 2 divided by 20 in the calculator, you get 0.1. But notice I'm writing 0.10. So you want to get in the habit of making your answers to 2 decimal places. It's the most commonly used format for your answers. It's the hundredths place. And if it comes out in your calculator as 0.1, we want to write 0.10 so we remember it's 10 out of 100, not 1 out of 100. So that's 10%, not 1%. So you'll notice I did 10%, I wrote 0.50, 0.40 instead of just using the 1 decimal place. I also did that up here and I didn't mention it, so I wanted to make sure that you saw that, and that was why I did that. So that I'm keeping all of my numbers to the same 2 decimal places. So these add up on the rows, but they do not add up on the columns. If I were to add them up on the columns, sometimes it's going to add up and be more than 1 because some of the numbers are bigger. Okay? All right, so that's how we make relative frequency tables. They're good for interpreting percentages of things. So here, if I wanted to use this to interpret this 10%, 10% of men prefer dance, 50% prefer sports, 40% prefer TV, or whatever the question was. We don't know what question was asked here. Women, 53% preferred dance, 20% sports, and 27% TV. Total, 36% preferred dance, 32% sports, and 32% TV. If I'm looking at the column version, then I would go this way. And I'd say 11% of men, 11% of the people that preferred dance were men, 89% of the people that preferred dance were women. 63% of the people that preferred sports were men, 38% were women. Men and women equally preferred TV, 50-50. 40% of the people surveyed were men and 60% were women. So it gives me a different way of talking about the data and looking at it in percentages. So the next thing that we're going to do is we're going to do some examples of two-way tables. So we're going to look at this page. You're going to get this page folded, unfolded. And you're going to have this on one side and this on the other side. And you're going to fold it so that this is the outside. So it makes a little book. Two-way tables on the outside. We're going to go over these couple examples. We're going to glue this in on the third page in our notebook. All right, a public opinion survey explored the relationship between age and support for increasing minimum wage. The results are summarized in the two-way table below. So we've got people who are for increasing minimum wage, people against increasing minimum wage, people with no opinion. We've got people ages 21 to 40, 41 to 60, and then over 60. So if I'm looking at the table and I asked the question, how many people were surveyed? We could look here to see that 200 people were surveyed. If I wanted to know how many people in the 41 to 60 age group were against raising minimum wage, we could look here, 41 to 60 and against, and we would say 35 people fit that description. 5 people of the 21 to 40-year-olds had no opinion. It means they didn't care whether they raise it or don't. So we can read lots of information from this two-way table, but we're going to look at a couple specific examples. In the 21 to 40 age group, what percentage supports increasing minimum wage? So first, it's asking percentage, which means I need to give my answer as a percent. Second, it uses the word support. So I don't see support up here, so we have to think of what does that mean. So support would mean that they're for increasing the minimum wage. So this means I'm looking for the word for. Okay? And I'm looking in the 21 to 60 age group, so I'm really only going to focus for this first question on this row. I'm not looking at all 200 people, I'm just looking at those 50 people. So I'm going to start writing this as a probability, because anytime I'm going to percent, if I can get my probability of that happening, then I can read the percentage from that answer. So what is it asking for? It's asking for, basically, I'm looking at the probability of what happening. Someone being in this group, 21 to 40 years old, and then of that group, people that are for increasing minimum wage. So I'm looking for those that are for minimum wage out of the 21 to 40 group. So it means I'm going to look at just these people, and there's 50 people in the 21 to 40 age group, so that's going to be my denominator. Out of those 50 people, 25 of them are for increasing the minimum wage. So 25 over 50. 25 over 50 is a half. If you divide that on your calculator, you get 0.5 or 0.50. So from there, if I want the percentage, I just read it from here. 50 out of 100 is 50%. So the answer to this question is 50%. I only need to go to this part if it says and asks for the percentage. If it asks for the probability, I would stop here with the fraction and the decimal. And here's my notation. All right, question 2. What percentages of people have no opinion regardless of their age? So when they say regardless of their age, that means we're going to be looking at all age groups, which essentially means I'm looking at the whole survey. And it's not important to me how it breaks down by age. I just want to know everybody. So that means I'm looking for the probability of someone having no opinion. So out of the 200 people, which is everybody in the survey, no opinion, we have 30 people have no opinion. So in my calculator, I'm going to do 30 divided by 200. It comes out to 0.15. So what percentage is that? That's 15%. % of the people that were surveyed had no opinion. So let's look at the examples on the inside. Okay. Here is the question. It's a little bit backwards on the inside here. Mr. Smith keeps track of his students' homework completion. He kept track of how many A block and B block students do not complete their homework. He puts students who don't complete their homework into two categories: first-time offenders and repeat offenders. He uses a table to keep track of the results. So here's his table. In 1 month, 36 A block and 12 B block students did not do their homework for the first time. 12 A block and 30 B block students did not do their homework again. Fill in the table. So let's read that again. In 1 month, 36 A block and 12 B block students did not do their homework for the first time. So those are first-time offenders. So 36 A block, so 36 will go here, and 12 B block. So that means there's a total of 48 first-time offenders. 12 A block and 30 B block students did not do their homework again. So those are the repeat offenders. So that was 12 A block and 30 B block. And so that's a total of 42 repeat offenders. Now, in A block, there's 36 plus 12, which is 48 total students in this table. In B block, there's 12 and 30, which is 42 total B block students. And then in the total, we have 48 and 42, which is a total of 90 students. So here's our table. Now, on the left side here, you've got some questions. It says, how many students did not complete all of their homework assignments this month? So if a student did not complete all their homework assignments, they were either a first-time offender or a repeat offender. So that means they would be represented in this table. So how many people is there altogether represented in this table? 90 students. What is the probability that a student chosen at random did not complete their homework, and that a student chosen at random did not complete their homework and they were in A block and a first-time offender? So we're looking at anyone who did not choose their homework, which is everybody in the table, and specifically we want people in A block and that are first-time offenders. So A block and first-time offenders, there are 36 out of everyone in the table, which is 90. So the way we would write our probability notation is probability of A block, and use the word and because they use the word and here. First time offenders, so I'm going to say first time. And that's going to equal, we said 36 A block first time offenders out of 90 students altogether. We divide that out. It's 0.4, so 0.40. And it doesn't ask for a percentage, it asks for the probability, so this is our final answer. This is how we got our final answer. So we want to show our fraction and show our decimal. So we're showing our thinking and how we got that decimal in case for some reason we get the decimal wrong. Also, sometimes you get the right answer with the wrong work, so you've got to show your thinking. Number 5. Are A block and B block students more likely not to complete their homework? Explain. So looking at the table, we got to use something to help us make that decision. Are A block or B block students more likely not to complete their homework? Explain. So take a second, look at the table, pause the video, come up with which one you think and how you can support that using math. Alright, so if we look at the table, we can use probabilities to help us support whether we think A block or B block are going to be more likely to not complete their homework. It depends really on what we're looking at. So there's a couple different things we can look at. We can look at what's the probability of each class not doing their homework, and we can also look at the probability that someone is a repeat offender in that class. So if we want to look at first, what's the probability that someone in A block is not doing their homework? Out of all the students who don't do their homework, we can say that 48 out of 90 students who don't do their homework are from A block. That is 0.53. So 53% of the students are coming from A block. Because it's a total of 48 students in A block not doing homework out of 90 students. We compare that to the probability of someone being in B block, that's on this list. We have 42 students out of 90 that are coming from B block, which is a 0.47 probability. So 47% of the people from B block are from B block. So there's more people from A block that are represented in this table, either on the first-time offenders or repeat offenders list, because there's 48, so there's more, the higher percentage of these than these. So that's one thing we could look at. We can say that A block students have a higher probability of not doing their homework in general, and that's one claim we could make. A block students have a higher probability of not doing their homework in general. And I'm going to put 53% in parentheses here because that was what we calculated. So A block students have a higher probability of not doing their homework in general, 53%. However, if we look at whether they're repeat offenders or first offenders, we can look a little bit more carefully at the data and look at and see what that shows us as well. We can look at two things. We can say, what's the probability that you're in A block and repeating versus what's the probability that you're in B block and repeating. So the way that would look is we would say the probability of being a repeat offender, given that you are from A block. And we can compare that to the probability of being a repeat offender, given that you're from B block. So to do that, we need to say, of all the people that are in A block, which is 48 people, we have 12 repeat offenders. So 12 out of 48 from A block are repeat offenders. That is a 0.25 probability. So a quarter of the class is continuously not doing their homework. Or a quarter of the people not doing homework at least once are continuing to not do it again. Same thing for B block, we're going to look at that. There are 42 people in B block, 30 of them are repeat offenders. So 30 out of 42 for probability of repeat given that you're in B block, and that's a 0.71 probability. So this data shows that there's a higher probability of, if you're in B block, that you're going to not do your homework a second time, versus A block has a lot of first-time offenders but not as many repeat offenders. So I'm going to say, however, B block students have a larger probability of being repeat offenders. And that was 71%. So we showed math to support both arguments. A block seems to have more, the most students that are not doing their homework, but B block seems to have a higher probability that people are going to continually not do their homework. So there's our reasoning for both of those, and how we used our probability and our thinking to help support our response. All right, so you can fold that in half, you get those glued into your notebooks on the 3 pages. Check the table of contents to see which pages they're supposed to go on, or the agenda, and then see what's next on the list to do. Thanks for watching.